Let's try and understand critical velocity in fluid mechanics. Think of river. River has streamline flow. Streamline flow is laminar flow, very peaceful flow. Alright. And then imagine when it's about to meet an ocean. So when it's about to meet an ocean, near the junction, it just changes from streamline flow to turbulent flow. So when it's about to meet an ocean, near the junction, it just changes from streamline flow to turbulent flow. You see here laminar, whereas here you are finding disturbance, and then it gets totally turbulent. Ocean, totally turbulent, where you also have whirlpool and you find it all going in a haphazard way. Now this situation where streamline flow is to be converted to turbulent flow, streamline flow is to be converted to turbulent flow, that velocity is known as critical velocity. And these are categorized by a number known as Reynolds number. Now Reynolds number 0 to 2000 is for streamline or laminar flow, and critical when it is about to get converted into turbulent, that value is 2000 to 3000, and turbulent is greater than 3000. Alright, so this is about number. Now what it is exactly, let's also understand what we have got scribbled over here. Flow of fluid, velocity at which streamline flow of fluid changes to turbulent flow is critical velocity Vc. Formula for critical velocity is Rn, coefficient of viscosity, density of fluid, and diameter of tube through which it is passing. Now for calculation we normally talk in terms of tube. Alright, so Vc is equal to Rn, eta, rho, and d, density. So Reynolds number Rn, its unitless number, coefficient of viscosity, eta, diameter of tube, and rho, density of fluid. So Reynolds number is just a mere number which has been assigned over here for varieties of fluid state. Let's now understand lamellar layer flow of viscous fluid. Now assume that a fluid is viscous and it is flowing on this floor. Alright. Now when it flows on this floor, it moves in form of lamellar layer. Alright, now like I have made here layers. This is one layer, this is one layer which is flowing, this is the second layer which is flowing, this is the third layer, fourth layer, fifth layer. For example, if suppose I have put in honey on floor, now it's highly viscous. Now how does it flow? It flows in laminar layers. Alright, now here I have shown one laminar layer, second, third, fourth, fifth, and so on and so forth. So it flows in laminar form, laminar layer form. And this is the floor. Now the first laminar layer which is on the floor, owing to friction, the layer hardly moves. So in fact, you have also observed, suppose you have put honey on table and if you try to wipe it out, you will find the lowermost layer will be sticking to the floor. So that's all because of force of adhesion doesn't let it move, and at the same time friction also doesn't let it move. Alright, now let's talk about the second laminar layer and third laminar layer, fourth, fifth, and sixth laminar layer, and so on and so forth. Now what happens in interlaminar layer? There is cohesive force acting, owing to which it doesn't let it slide freely. Alright, but definitely it slides. whereas this is stagnant. So this slides more than this. So the velocity with which it slides, I call it as V. Similarly, when we go to third laminar layer, here again cohesive force is there, but this slides little more than the previous one. So I call it as V plus dV. Alright, and so on and so forth. The layer keeps on sliding, the uppermost sliding the most, whereas lowermost not at all sliding or sliding the least. Alright, I give you the reason why this doesn't or hardly slides the lowermost layer and why the uppermost layer slides most. Alright, so the velocity of the topmost layer would be the fastest, and that's what we observe. When you put honey on table, we'll find that the upper layer is moving quite faster, whereas the lower, it remains sticky there, though the fluid may move like that, but the lowermost level here would be sticky, whereas this would be flowing much faster. So that's what we observe. Alright, so that's why we categorize it as, now here I call it as V is equal to 0, here I say it as V, velocity is equal to 0, here I say velocity is equal to V, here I say velocity is equal to V plus dV. dV is just the difference between the two, and so on and so forth. Alright, now if I talk about distance, the distance of this from floor, if I calculate the distance of this first laminar layer, x is equal to 0. For the second laminar layer, let's assume it to be x, and the third laminar layer, it will be x plus dx, and so on and so forth. Alright, okay, now this is what, as I mentioned, schematic laminar layer flow diagram of viscous fluid flowing. Alright, I hope this part is clear. Now all this I explained first of all to talk about viscosity, how cohesive force, interlaminar cohesive force restricts the flow. I also explained that the lowermost layer doesn't move or hardly move owing to adhesive force and frictional force. Alright, now all this also I explained in order to make you understand velocity gradient. Now velocity gradient is one of the terms which is very frequently used in viscosity. Velocity gradient is dV by dx, that is difference in velocities between laminar layer upon difference in distance of those layer from the floor. Alright, so dV by difference in velocity upon difference in distance, that is called as velocity gradient. Anyway, we also have learned potential gradient. Potential, this is not irrelevant with this. This is just, since gradient word I have used, so I am just trying to bring to your notice that volt upon length also is gradient, that is potential gradient. Okay, so coming back to our, what we were talking about, velocity gradient is dV by dx. So now can you tell me, now suppose a big pipe through which water is flowing and a river where water is flowing. Can you say which laminar layer would move the fastest and which the slowest? So I have made here one laminar layer, two laminar layer, two laminar layer, three laminar layer, and the fourth one. Here also we have 1, 2, 3, 4, 5 like that. The central laminar layer would be moving the fastest, and here in case of river, the topmost would be moving the fastest. Now one which is adhering to the surface of pipe, one which is adhering to the bed of river, will have maximum friction, and maximum force of adhesion. Velocity would be restricted, whereas it would keep on, the velocity would keep on increasing and would be maximum here. So the velocity would keep on increasing and maximum would be here. Alright, so this is what I just wanted to bring to your notice about velocity gradient and about viscous fluid how does the laminar layer flow in a viscous fluid when it's flowing. All right.